We're here to talk about the real numbering system today. We'll talk about the imaginary numbers at a later date. We're going to explore some subsets of the real number system. All right, so we have the rational numbers that are denoted capital Q. We have the integers, which are a subset of the rational numbers, denoted capital Z. All right, I put a line through my Z to distinguish it from a 2, and I would recommend you do that as well. We have the whole numbers, capital W, and we have the natural numbers, capital N. All right, those are all subsets and supersets of each other. All right, we also have, if a number is not rational, it's irrational, capital I. All right, what we're going to do is we're going to focus more on the rational numbers and the subsets thereof right now, and then we'll talk about irrational numbers. We will come back and talk about imaginary numbers at a later time in our studies this year. All right, so we'll start by talking about rational numbers. Now, in math analysis, we're kind of graduating, progressing through our studies into higher level math. And this is really the last high school level math class we'll take, because next year you'll be taking calculus, and calculus is really a college level class. So we have to make sure that we focus on proper mathematical terminology, defining things properly, and things of that nature, right? Staying away again from gimmick math. So a lot of times people will say a rational number, oh, that's a fraction. And that's not a precise definition, because there are fractions that are not rational numbers. Okay, so rational number is any number that can be expressed in the form a divided by b where a and b are both integers and b is not equal to 0. Okay, because we remember that division by 0 is undefined. Okay, and we'll remember also that a non-zero number divided by 0, that's undefined. If we have 0 divided by 0, that's not the same thing. That's indeterminate. There's a difference between these two, and again, it goes to the precision that we're going to be using in our studies this year in math analysis and next year in AP calculus. So we're going to talk about this right now. Some things that you've learned incompletely and therefore incorrectly. Now, you probably learned, like I did, how to divide in second grade. And in second grade, your teacher probably thought he or she was helping you out by saying, giving you these rules. And a lot of times those rules aren't really rules. They're more tips or gimmicks, which are tricks. All right. So we want to stay away from them. They probably told you that any number divided by itself is 1. And then maybe the next day or later that day, they said 0 divided by any number is 0. And fast forward to when you're in middle school, your teacher probably told you that division by 0 is undefined, that you can't split something into 0 parts. But now we have 0 divided by 0, so we're going to talk about that. So some people might say 0 divided by 0 is 0. Some people might say it's 1. And some people might say it's undefined. All right. And the reason for that, and it goes into what psychologists refer to as cognitive dissonance, is that you were told that a number divided by itself is 1. You were told that 0 divided by a number is 0, and any number divided by 0 is undefined. Now, this is all three of those. It's a number divided by itself, it's 0 divided by a number, and it's a number divided by 0. The problem is that all three of those things had stipulations to them that were left off because you didn't need them right then. So in second grade, your teacher should have told you that any number divided by itself is 1, provided that that number isn't 0. And that 0 divided by any number is 0, provided that that second number isn't 0. And it should be that a non-zero divided by 0 is undefined. All right, so a number divided by 0 is undefined, provided that that number is not 0. So this is, now we're looking at those things with the stipulations. This is all three of those things. So this is what we call an indeterminate form. And indeterminate by nature means that you can't make a determination. It means further analysis is necessary. So throughout the course, we're going to be looking at how we deal with things when a 0 divided by 0 indeterminate form comes up. It means that further analysis is necessary, so you can never stop when you get to 0 divided by 0. And that's going to be a recurring theme throughout this course. Okay, so now that we have a more complete discussion of rational numbers, we're going to move on. But I almost failed to mention, what you might want to do is, after I get done with this part, press pause. If you have a Siri-enabled device, I want you to bring Siri up and ask Siri what 0 divided by 0 is, and she will have an interesting dissertation on that for you. All right, now the way that we learn numbers is we start first with natural numbers. All right, that's what we learn first when we learn how to count. Okay, they're 1, 2, 3, 4, ellipsis, that's the positive integers. So when you're first learning to count, say in preschool or before then, somebody says, how many noses do you have? You say 1. How many eyes do you have? 2, etc. How old are you? Hold up 3 fingers for 3, etc. Then sometime later in your studies, you learn about the concept of 0. All right, so a lot of times young kids will struggle with the fact that when somebody's born, they're not 1 year old. They're also really not 0. That's why we talk about newborns in terms of days and weeks and months, so we don't have to say they're 0 years old. All right, these are the non-negative integers. And remember, non-negative and positive do not mean the same thing. The difference between the two is the inclusion versus exclusion of 0. So we can't use those terms interchangeably because they're not. Now, they're almost the same, but almost the same isn't good enough. Okay, now when we start talking about integers, that's later in our studies, we start to talk about negative numbers. Right? So we have ways of representing losses. Now, certain civilizations didn't have the concept of 0 in their numbering system. So when we write in English, we use the Latin alphabet or the Roman alphabet, origins in the Roman Empire. But we don't use Roman numerals, we use Arabic numerals. And a main reason for that is that the Romans did not have a concept of 0 in their numbering system. So there's no Roman numeral for 0. Okay? And then we get into irrational numbers. Okay? We'll talk about irrational numbers which aren't a subset of the others. An irrational number, really we define it as anything that's not rational. So any number that cannot be expressed in the form a divided by b, where a and b are integers and b is not equal to 0. So we really don't have a separate definition of irrational other than to say it's something that's not rational. So square root of 2 divided by 2, that's why we can't say that a rational number is just a fraction, because square root of 2 divided by 2 is a fraction, but it's not rational because square root of 2 is irrational. All right, and square root of 2 is a non-terminating, non-repeating decimal value. All right, so its only exact value is the square root of 2. All right, pi is irrational. All right, when you hear about 22 sevenths, 22 sevenths is a not so great rational approximation of pi. All right, square root of 5 is irrational. Square root of 8 is irrational, unsimplified though. We could simplify it to 2 square root of 2. That's also still irrational. And something like 1 divided by square root of 7. All right, That's also irrational because the numerator and the denominator are not both integers. Square root of 7 is irrational. Now, contrary to popular belief, all right, you don't have to rationalize these things. And if you do want to rationalize it, that's fine. There's actually no real valid mathematical reason for we don't why we have to rationalize it. Also, you probably never learned how to rationalize when there's a cube root or a fourth root or something else other than a square root in the denominator. That's going to be another rant for another time. So we'll get to that. We'll also talk about why people would rationalize this. And it goes back to a calculating device. It's not an ancient calculating device, but they were used about maybe, I'll say 60 years ago, 50, 60 years ago, maybe a little bit longer, called a slide rule that people used to do mathematical calculations on. Okay, so irrational is any number that cannot be expressed in the form a divided by b, where a and b are integers and b is not equal to 0. All right, so that's some groundwork with our numbering system, our real number system, and the subsets thereof that we're going to cover. And we'll be doing some follow up in class. Remember, you can always go back and rewatch this video, rewind, pause, etc. Make sure that you have thoroughly annotated notes, because if your notes aren't good, then that's slightly better than having no notes at all. Okay, so we'll see you soon to follow up with this.